Good evening everyone. Today we'll be learning about the maximum power transfer theorem. First, let us understand the statement. To obtain the maximum power in any network, always the load resistance should be equal to the Thevenin's resistance. That is, RL is equal to RTh. When you have learned about the Thevenin's theorem, you have seen the circuit diagram where VTh and RTh will be connected in series to your load resistance. Here, when we try to calculate the current will be equal to V by R. Here it is VTh by RTh plus RL, as load resistance is connected in series with VTh and RTh. Next, as we all know, power in DC circuits has two formulas, which is V into I and I square R. Here we are going to use I square R formula. So power is equals to I square into RL. So next, power is equal to, here whatever I we have got here, we'll substitute that in the place of I in this power equation. So we will get this equation. After that, now we can observe that if we increase RL here, power will be increased. But if we increase RL here, current will be decreased. When current is decreased here, power also decreases. To understand it in the better form, we have a graph over here. First, when RL increases, power also increases. But gradually when RL increases for the maximum value, current also increases and the power decreases. Therefore, when RL increases slowly, power also increases, but at certain point of time, as current decreases, power also decreases. So this is the graph of the understanding of this equation. Next, here is the maximum power obtained. So when we consider a slope here and the corresponding RL value will give us maximum power. Next, we can find that slope of a tangent, that is dP by dRL will be equal to 0. Next, here in this equation, in this power equation, we are going to expand this equation. When we expand the equation by squaring this term, we get this term. Here, there's an understanding. We can differentiate it in two ways. One way is dP by dRL is equals to 0, and the other way is dRL by dRL. The other way is this denominator with respect to RL will be equal to 0. Okay, so we have two ways. Why this denominator with respect to RL is equal to 0 is when the power is maximum, this term is very minimal, right? So when this term is minimal, we can equate it to 0. That is why we can differentiate this directly and equate it to 0 with respect to RL. That is what we are doing here. This denominator, we are differentiating it with respect to RL. This RTh square by RL, when we do it with respect to RL, we will get this term. Then this term will be 0 because there is no RL term here. This is 1. From this equation, we will get RL square is equal to RTh square. That is nothing but RL is equal to plus or minus RTh, which is required condition for maximum power. Now, we'll see how to find Pmax. That is VTh square by RTh plus RL whole square was the equation. Here RTh is equal to RL. So 2 times RTh whole square into RTh, we will get VTh square by 4 RTh, which is required power max. Thank you. If you like the video, like, share and subscribe to Vlogs with Sai Inshira. Have a good day.